So again we will solve a few problems on 1D kinematics. So we will start with this overtaking problem. So this, and there are two cars running one after the other. This car, car A, and one more car B behind A. Okay. Now this length of the cars is also given. So this is L1, and the length of the car B is given as L2. And here the distance between the car at this moment is given as d, and they are having velocities. Say at this moment, say velocity of car A is equal to 0 and velocity of car B is equal to u. And say, let me write the statements. Let me put the statements in order like this. Say car B is distance d behind car A. Then car A starts to move, starts from rest with constant acceleration, A. There, constant acceleration of car A is equal to small a, right? While car B continues to move with constant velocity u, equal to u. Now it's given that, so it has been asked that after what time will B overtake A? That is the question. So I have to draw the diagram again. Don't worry, it will take a few seconds. There it is. Quickly, car B and that was car A. Distance between the cars is d, length is L2, this is L1. Okay, so it moves with constant velocity u and it starts from rest with constant acceleration a. So overtaking of the car means at say after time t, B overtakes A. That means this is A. It looks more like a chair. Don't worry. Yes. So that means B is here. Just it crosses A. The rear end of B just is in line with the front end of A. So this means overtaking. So we'll assume that let B overtake A after time t. Overtake A after time t, right? So in time t, you have to see how much distance the cars has moved. So in time t, say this car A, this end will move how much distance? It starts from rest, so ut plus u is 0, so it moves the distance half at square, and car B moves the distance how much? It is having no acceleration, so it is moving a distance ut. Okay, So here at this state, uh, B overtakes A, just overtakes A. This situation is at time 0, this is at time t. Okay. So now framing the equations is nothing, all is given in the diagram. See, this is how much length, this is L1, so it's all in the diagram. See, you see ut is equal to half at square plus d plus L1 plus L2. So half at square minus ut plus this whole thing d plus L1 plus L2 is equal to 0. So you get time is minus b plus minus root over of b square minus 4, that means 2a into d plus L1 plus L2 divided by a. Obviously we will choose the, okay, there are two values, however, so that means that it may happen that a and b can meet twice. A and b can meet twice because both are possible values of time, right? Because this u and this is plus minus root over of u square minus, so this root over of this quantity is less than u, so time is not taking a negative value, so they will meet at two values of time. Okay. Now the after what time, so you can have two answers, obviously no problem with that. Now in the same problem it may be asked that, so to find the condition so that B can never overtake A. So some condition is there, so you see what you have to do. That means after solving for t, you will get an impossible value or imaginary value. So this quantity is known as the discriminant. So discriminant should be less than 0. So if B cannot overtake A, then T will have imaginary solution. That means the discriminant, this u square minus 2a multiplied by this d plus L1 plus L2, this is less than 0. So that is u is less than this root over of 2a d plus L1 plus L2. Even in this problem someone may also ask you, and sometimes these questions are also asked. So find the road distance in overtaking. So the road distance used by B is this distance, right? So with this ut you have to add this L1. So that depends, when you encounter such problems then you can go ahead. Okay, let's solve some more problems. Number 2. In the problem it is given that, say, when a train, a moving train right, train is moving, rather the front end of the train, the front part rather, the front part of the train crosses a post with speed u, while the rear part crosses with speed v. Okay, what was I trying to write here? That a moving train has length L. I forgot that. Moving train and length L. The front part of the train crosses a post. Post means a lamp post or whatever. It will be stationary. While so front part crosses the post with speed u, rear part crosses with speed v. Now find the acceleration of the train. Find acceleration of the train and speed with which the midpoint of the train crosses the post. The speed with which the midpoint of the train crosses the post. See, it's like this. Train, and say this is a post, stationary. So the front end of the train crosses the post with the speed u, and when the rear end of the train, so that means now the train in a next diagram, just below it the post is stationary, rear end of the train crosses it with speed u, v, speed v. So obviously this is the length of the train L, so find acceleration of the train. And also in the last part it is asked that with what speed the midpoint of the train crosses the post. There it is, right? So that is L by 2. Suppose the midpoint of the train crosses the post with a, you assume some speed, say it's v dash. Okay, so now you see, now here this point of the train has velocity u. Now as rear end crosses with v, also all points of the train has same speed. So this has speed v. So that means for this particle, when it traverses a length L, the speed changes from u to v. So there we will apply v square, final velocity. After traversing we are concentrating on this point on the train. Here also this point of the train. So v square equal to u square plus 2a times L. Now see, a is acceleration of the train. So a equal to v square minus u square by 2L. So that is the answer to the first part. Okay. See, the next part you have to find v dash. So that means the question is that what is the velocity of this particle p when it covers a distance half L. So we can write v dash square equal to u square plus 2a into L by 2. So v dash square equal to u square plus 2 u square plus al. So L into a, L put for a, v square minus u square by 2L, and accordingly you solve for v dash. Now let's look at this problem. A particle travels fast t1 seconds with constant acceleration a1 starting from rest, the next t2 seconds with uniform velocity, and in the next t3 seconds retards and stops. Find its total displacement. So this problem without using the equation, I will solve it by graphical method. You know, acceleration, if it is constant acceleration, then Vt graph is a straight line, and this acceleration is nothing but slope of that straight line, slope of the Vt curve. So this is it, V and T. So it starts from rest, here at time. Okay, so this is, just divide the times t1, and next time t2, and next time t3. Okay, so constant acceleration, so it will go up to this velocity. Constant acceleration means this, you know, that this tan theta is a1, so that is v by t1. If this velocity is v here, so it continues with the same velocity for next t2 seconds, and then it retards, and it is given retards uniformly, else you cannot be sure that whether this curve is a straight line or not. Oh, that is given, I forgot to mention. So here it is, it's a straight line. See, it stops means final velocity is 0. So the total displacement is equal to the area of this trapezium. So that is equal to half sum of the parallel sides. Half sum of this parallel sides is how much? T1 plus T2 plus T3 plus T2 again, multiplied by distance V. So that is half of, see, this is T2, so half of T1 plus T3 plus 2T2 multiplied by V is A1 T1. That is it. This is displacement. So this is a very short way of solving the problem. Else you have to write the equations. Now next problem, a particle has velocity depending on time as this, v equal to t square minus 4t. Obviously you know that this is a case where velocity is a quadratic equation in time, so acceleration won't be constant. By the way, you have to find the time interval for which the particle is accelerating, is retarding. See, lot of students have misconception. They tell that okay, retardation is negative acceleration. So what is positive and what is negative? Say if I choose the direction towards the right, positive, and the acceleration is this way, will it be retarded? No, not necessarily. If your friend chooses the axis here, then your friend will say okay, the acceleration is this way, this is accelerated, while if the acceleration is this way, then it is retarded. So that is not the proper way of approaching, that is misunderstanding the situation. You know, what is accelerated motion? Accelerated motion means where the speed is increasing, speed increases with time, and retarded motion, their speed decreases with time. That means one is speeding up, so that is, it is in one word, this is speeding up, and this is slowing down, right? So accelerated motion happens when the velocity, we are talking about straight line motion, so this velocity and acceleration are in the same direction, it is accelerated motion, while retarded motion if they are in opposite direction, right? See, acceleration, whether it is accelerated or retarded, does not depend on the sign of acceleration. It depends on whether acceleration and velocity are in the same direction or in opposite direction. So this is slowing down. See, acceleration towards the left here means there is a force, so the body is trying to move this way and force is trying to pull it this way, so obviously it will be slowing down. And here body is moving this way and the force, you know, acceleration and force are in the same direction, Newton's second law. So the force is also pulling this particle, so it will speed up obviously. So this is the equation V equal to t square minus 4t. Now this acceleration is this, so it's 2t minus 4. Now, so we have to look at the signs of velocity and accelerations. If they have same signs, that means, see, if you choose this sign positive this way, so towards the right, so if V and A are here or V and A are here, both are accelerated motion. And if V and A are here or V and A are like this, so that is retarded motion. So this is accelerated and this is for retarded motion. Okay, so according to the equations, V is t square minus 4t and A is 2t minus 4, that is A is 2 into t minus 2 and V is t into t minus 4, so t minus 0 into t minus 4. Okay, so you know, in maths there is a technique of wavy curves, you may have learned it. This is time. See, here you have 0, so put 0 here, 4 here. Okay, for velocity, say choose any value of time between 0 and 4. So let us choose a value like 2 or 1, whatever. So if t is equal to 1, then what is the value of V? See, if t equal to 1, then V equal to 1 minus 0 multiplied by 1 minus 4, that is minus 3. So for all values it's negative. So at 0 and 4, obviously they are 0, so it's negative. So in the interval from 0 to 4, V is negative. We don't have to draw the exact nature of the curve, just the signs. Okay. Now, so from 4, you can check it out. You can take a value more than 4. Say, let's take it 5. So 5 minus 0, 5 minus. So that's positive. And also you can take a value less than 0. So suppose take it minus 1. So then also it is positive. So this is for V. And now we'll check for A. I mean the signs of A. A by this brown. So now A is t minus 2. So there is this 2. So you know it's a straight line. So more than 2 positive, and less than 2 negative. Okay, now we will see in which intervals the particle is accelerating and retarding. Say this is one interval, this, so we have divided actually into 4 intervals: less than 0, 0 to 2, 2 to 4, and beyond 4. So let's check it here. In this interval less than 0, V is positive, this blue one for V and brown for A. So this is V is positive and A is negative, so that is retarded. So R for retarded, and here from 0 to 2, A is negative and V is negative, so this is accelerated. Now here from 2 to 4, V is negative and A is positive, so that is retarded, and more than 4, both are positive, so it is accelerated. So that is the interval in which particle is accelerated and retarded motion.